Welcome back. Today we'll be doing IGCSE Math 0580 Extended Unit 8 Probability. So first, introduction to probability. For the notation of probability of an event A, we use the notation PA. This means the probability of event A. For example, a coin with a head and tail. And the probability, for example, A equals head. The theoretical probability of PA is 0.5. And A prime means the probability of not A, which is also 0.5, it is equal to 1 minus probability of A. So probability of A prime plus probability of A should always be 1. It doesn't have to be A, it could be B, it could be C, it could be D, it could be anything. So remember, this notation means not probability of A, which is 1 minus the probability of A. And a probability can never exceed 1. It will always be smaller or equal to 1. We can see this as percentage. So this would be 100% of success. You cannot have 200% of success, but you can have 50%, 0%, and you cannot have negative percent. Now, we should talk about relative frequency. So we know that for a coin to be tossed, the probability of head is 0.5. This is theoretical probability. So when you actually perform an experiment, flipping a coin like 1,000 times, there could be 498 heads and 502 tails. If you flip it 10 times, it could be 3 heads and 7 tails. So in this case, the relative frequency of head would be 3 over 10, which is 0.3. And in this case, it would be 498 over 1,000, which is 0.498. And now the expected frequency. The expected frequency is number of trials, T, times the theoretical probability. So PA theoretical, TH, let's say. So the expected frequency of a heads, number of heads for 1,000 toss would be 0.5 times 1,000, which is 500. Now, after we know relative frequency and expected frequency, we can tell if the event is biased or fair. So bias, for example, I have a coin and the probability of getting a head, P head, equals 0.3. The theoretical frequency would be 0.5, but it's not 0.3, so this coin is biased. Now, probability of combined events. So first, let's talk about if the events are independent. For example, probability of head of a coin and 1 in a dice. It would be probability of head would be 1 over 2, and probability of 1 in a dice would be 1 over 6. And it's multiplication, because you need one to be a head and the other to be a 1, which is 1 over 12. If it's asking for the probability of head or 1. Then we'll have probability of head plus probability of 1 minus probability of head and 1. This is because if you see it in a Venn diagram, with this being head, this being 1, probability of head is this, then if you add probability of, where's my pen? Here, probability of 1, then there will be a part where it overlaps. So we minus the overlapping part, leaving it probability of head or 1. And now further on, if have probability of head given 1, this means that 1 already happens. What's the probability of a head? It is probability of head and 1 over probability of 1. You can see this in a Venn diagram. So probability of head given 1 is that we know that 1 is already happening, so we need the probability of this circle. And in this circle, what's the probability of getting the head is here. And this is head and 1, the green part. Now, 2, if they're dependent, for example, the day it's going to rain, yes, is 0.2. It's not going to rain, therefore is 0.8. If it rain, probability of me wearing a hat, yes, is 0.7. Then not wearing a hat is 0.3. If it is not raining, probability of me wearing a hat would be 0.4. Then not wearing a hat would be 0.6. So here would be 0.14. This would be 0.06. This would be 0.32. This would be 0.48. Now these all adds up to 1, so it makes sense. And now we want the probability of hat given rain. So the probability of hat and rain is rain hat 0.14, and the probability of rain is rain 0.14 plus, let's write it here, 0.14 plus rain no hat 0.06, which is 0.14 over 0.20. Thus 0.7, which is the probability of wearing a hat when we know it is raining. So this is a tree diagram. Now, if it is 0.5, if it is 0.5, then the coin is fair. Now, another classic example of a dependent probability is I have a bag, and there are 3 red balls, 2 blue balls, and 1 white ball. What is the probability of getting 2 red in a row? So when I take 1 red, the first probability would be 3 over 6, because there are 6 in total and 3 of them are red. Then I times 2 over 5. This is because after the first red ball being taken, there are only 5 balls total and 2 of them are red. Now move on to the third type of diagram. We have sample space diagram, which is literally listing out all the possible outcomes. So 2 dice are rolled, and the results are added. So the sample space diagram would then be 1, 2, 3, 4, 5, 6, which is the possible outcome for dice 1. And now dice 2, possible outcome 1, 2, 3, 4, 5, 6. And add them up, we have 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Now the probability of getting a 12 would then be 1 over 36. Probability of getting a 6 would be 1, 2, 3, 4, 5, 5 over 36. So if the possible outcomes are limited to a very small number, a sample space diagram would be a better choice. And that's it for today. Thank you for watching.